Imagine waking up tomorrow morning to a strange, unsettling silence. Not a silence you can hear, but one you can feel. The kind that comes from something ancient and constant simply not being there anymore. You check your phone. No storm warnings, no headlines about an asteroid, nothing unusual at all. But when night falls and you step outside expecting to see that familiar pale disk rising over the horizon, there's nothing there. No craters, no glow, no shifting phases, just an empty patch of black sky where the moon used to be. Within hours, telescopes across the planet confirmed the impossible. Earth's only natural satellite, our companion for over 4.5 billion years, is simply gone. Now, before we go any further, let's be honest about something. In the real world, a ball of rock more than 2,000 miles across, weighing in at roughly 81 quintillion tons, cannot simply vanish. Doing so would violate some of the most fundamental laws of physics we know, the conservation of mass and energy chief among them. There's no known mechanism, natural or otherwise, that could make the moon disappear in an instant without unleashing energy on a scale that would make the disappearance itself the least of our problems. But that's exactly what makes this such a fascinating thought experiment. By imagining the moon simply gone, quietly and cleanly, we get to ask a far more interesting question. Just how much of our world, our biology, our culture, and even our history has been quietly shaped by that one gray rock in the sky? The answer, as you're about to find out, is almost everything. Let's start with the most immediate and physically obvious change, the tides. Most people know the moon causes tides, but few really understand how. The moon's gravity pulls on Earth, and because the side of Earth facing the moon is closer than the side facing away, it gets pulled slightly harder. This difference in pull, called a tidal force, stretches Earth's oceans into a subtle oval shape, with bulges of water on both the near and far sides of the planet. As Earth rotates underneath this stretched shape roughly once a day, most coastlines experience 2 high tides and 2 low tides every 24 hours. The sun also pulls on our oceans and creates its own smaller tidal bulge, but because the sun is so much farther away, its tidal effect is only about half as strong as the moon's, even though the sun is vastly more massive.
So what happens the moment the moon disappears? The lunar tidal bulge collapses almost instantly. What's left behind is only the sun's much weaker pull on the oceans. Tides wouldn't vanish completely, but they would shrink dramatically, dropping to somewhere around a third of their current range. The dramatic swings we see in places like the Bay of Fundy in Canada, where tides can rise and fall by over 15 meters, would become a distant memory. Most coastlines would settle into a gentle, barely noticeable rhythm of water rising and falling by only a few centimeters, and the powerful twice-daily rhythm that has pulsed through our oceans since before life even crawled onto land would fade into something closer to a ripple. This might sound like a minor inconvenience, but for entire ecosystems, it would be nothing short of catastrophic. Intertidal zones, the areas of coastline that are submerged at high tide and exposed at low tide, are home to an extraordinary density of life. Barnacles, mussels, crabs, sea stars, anemones, and countless other species that have evolved over millions of years around the rhythm of the tides. Many of these organisms rely on that twice-daily flooding to feed, breathe, and reproduce. Without strong tidal cycles, these zones would shrink and destabilize, and the species living there would face a slow but severe ecological collapse. Coral reefs would suffer too, in ways you might not expect. Many coral species time their mass spawning events when they release eggs and sperm into the water in perfect synchrony to the phases of the moon. It's one of the most precise biological clocks in nature, entire reef systems releasing genetic material within the same hour, on the same night, once or twice a year, guided by moonlight and tidal cues. Remove the moon, and that synchronization falls apart. Coral reproduction becomes scattered and inefficient, and already stressed reef ecosystems would lose one of their key survival mechanisms. Sea turtles, which use moonlight and tidal patterns to time their nesting and guide hatchlings safely to the ocean, would face similar disruption, as would countless fish species like the grunion, which strand themselves on beaches during specific high tides to lay their eggs in the wet sand.
And because ocean ecosystems are so deeply interconnected, this disruption wouldn't stay contained to the shoreline. Fish populations that spawn according to tidal cues would decline, and the predators that rely on them, from seabirds to larger fish to marine mammals, would feel the effects ripple outward. Coastal fishing communities around the world, many of which have built their entire way of life around the predictable rhythm of the tides, would find their harvests smaller and far less predictable. In short, losing the moon wouldn't just quiet the oceans, it would quietly starve them. Now let's talk about something you'd notice almost immediately, every single night: the darkness. A full moon can be bright enough to cast shadows and let you walk outside without a flashlight. Without the moon, every night would be as dark as the darkest nights we currently experience only around the new moon when it's absent from the sky, except this darkness would be permanent. For city dwellers surrounded by streetlights, this change might barely register, but for the roughly 1 in 10 people on Earth still living without reliable electricity, and for the wildlife everywhere, this would be a profound shift. Nocturnal animals have evolved intricate relationships with moonlight. Dung beetles and certain moths use the polarized light of the moon to navigate in straight lines across the night sky. Predators like lions have been shown to hunt more successfully on darker, moonless nights when their prey can't see them coming. In a permanently moonless world, this advantage wouldn't come and go with the lunar cycle anymore. It would simply become the new normal, tilting the balance of power between predator and prey species in ways that would ripple through food webs for generations. Some nocturnal species that rely on moonlight to navigate migratory routes, like certain birds and insects, could lose their way entirely, while others that avoid moonlit nights to stay hidden from predators would suddenly find every night equally safe and equally dangerous in different measure.
Look up on any clear night after the moon is gone, and you'd actually notice something beautiful before you notice what's missing: the stars. Without lunar glow washing out the sky, the Milky Way would become visible far more often, and stargazing would improve dramatically for everyone, every night, not just during the new moon window astronomers currently wait for. But there is a trade-off, and it's one of the most poetic losses in this entire scenario. The total solar eclipse would cease to exist forever. Here's why that matters so much. Through one of the most remarkable coincidences in our solar system, the moon is about 400 times smaller than the sun, but it also happens to be about 400 times closer to Earth. That means, from our exact vantage point, the moon and sun appear almost precisely the same size in the sky. This is why, during a total solar eclipse, the moon can slide directly in front of the sun and blot it out almost perfectly, revealing the sun's ghostly outer atmosphere, the corona, for a few breathtaking minutes. No other known planet in our solar system has a moon that creates this exact effect. Without the moon, that phenomenon, one that has inspired myths, scientific discoveries, and pilgrimages across cultures for thousands of years, would simply never happen again. Lunar eclipses, of course, would vanish too, for the obvious reason that there would be no moon left to fall into Earth's shadow. Now we move from the things you'd notice within days to something far more profound and far slower: the long-term stability of Earth itself. Earth spins on a tilted axis, currently at about 23.5 degrees, and that tilt is the reason we have seasons. What most people don't realize is that this tilt isn't naturally stable on its own. Left completely to itself, without the moon's gravity acting like a steadying hand, Earth's axis would be vulnerable to chaotic wobbling caused by the gravitational tug of the other planets, particularly Jupiter and Venus.
Some scientific models suggest that without the moon's stabilizing pole, Earth's axial tilt could drift unpredictably over millions of years, potentially swinging between very small angles and much larger ones, in some simulations wandering across dozens of degrees rather than staying locked in a narrow, gentle range. Compare that to Mars, a planet with 2 tiny, negligible moons, whose axial tilt has been shown through modeling to have swung significantly over its history, contributing to dramatic long-term climate shifts on that planet. If Earth followed a similar chaotic path, we could see wild and unpredictable swings between extreme seasons, ice ages arriving and retreating unevenly across different regions, and long-term climate patterns becoming far less stable and far less hospitable for the kind of complex, settled civilizations we've built. This wouldn't happen overnight. It would unfold over hundreds of thousands or millions of years, but it represents one of the quietest and most important jobs the moon has been doing for us this entire time, acting as a gravitational anchor that keeps our seasons, and by extension our climate, relatively predictable. There's another slow-motion process the moon has been driving for billions of years, and its disappearance would actually stop it in its tracks, the lengthening of our day. The moon's gravity doesn't just pull on our oceans, it also creates friction with Earth's rotation, acting like a very, very gentle brake. Because of this tidal braking, Earth's rotation is slowing down by a couple of milliseconds every century, and the moon itself is drifting away from us by roughly 3.8 centimeters every year, a rate about as fast as your fingernails grow. Billions of years ago, in Earth's early history, a day was only about 6 hours long. Thanks to the moon's gentle braking effect, we've ended up with the 24-hour day we know today. If the moon vanished, this braking effect would stop completely. Our day length would simply freeze at whatever it currently is, rather than continuing its extremely slow march toward longer days over the coming eons. It's a change so gradual that no single generation would ever have felt it either way, but it's a striking reminder of just how much of Earth's rhythm has been shaped by a rock 238,000 miles away. Let's shift now from the physical world to something just as real but far more human: culture. For nearly the entire span of human history, the moon has been our clock in our calendar. The very word month comes from the word moon. Ancient civilizations across the world, from Babylon to China to the early Islamic world, built their calendars around the roughly 29.5-day cycle of the moon's phases. Even today, the Islamic calendar is a purely lunar calendar, with the beginning of each month and sacred periods like Ramadan determined by the sighting of the new crescent moon. The Jewish and Chinese calendars are lunisolar, blending lunar months with the solar year to keep festivals aligned with the seasons. If the moon disappeared overnight, these systems, deeply woven into the religious and cultural practices of billions of people, would be thrown into immediate crisis, forcing entire faith traditions to rapidly redefine centuries, even millennia of established practice. Beyond calendars, the moon has been a canvas for human imagination since before written history. Nearly every culture on Earth has its own mythology built around it. The Greeks had Selene, goddess of the moon. The Chinese have Chang'e, who famously flew to the moon and still lives there in legend. Ancient Egyptians worshipped Khonsu, and countless indigenous traditions across the world tell stories of a moon spirit or a rabbit or a figure living within its bright face. Poets have written about it for thousands of years. Songwriters still reference it in nearly every genre of music, and it has become deeply woven into how we express love, longing, and wonder. Its sudden disappearance wouldn't just be a scientific event, it would be a profound psychological shock to the entire species. Something that every single human being who has ever lived has looked up and seen would simply not be there anymore. We should expect confusion, fear, religious upheaval, entirely new belief systems, and doomsday movements forming almost overnight, and a kind of collective grief for something most people never realized they were even attached to until it was gone. Meanwhile, in laboratories and observatories around the world, scientists would be in a state of complete emergency. Astronomers, physicists, and planetary scientists would scramble not just to understand what happened, but to figure out whether it could happen again, whether it might be connected to some larger threat, and whether Earth itself was now in any kind of danger. This alone would likely become one of the largest coordinated scientific efforts in human history, with governments and international space agencies pooling resources almost overnight to understand an event that, by all known laws of physics, should have been completely impossible in the first place. Speaking of physics, let's briefly touch on what such a sudden disappearance would actually mean for Earth's orbit and stability, even if we accept it as a strange, unexplainable event. The Moon's mass is only about 1.2% of Earth's mass, and Earth and the Moon actually orbit a shared center of gravity called the barycenter, which sits just below Earth's surface. If the Moon vanished, Earth would essentially just orbit the Sun on its own from that point forward, and because the Moon's mass is so small compared to the Earth-Sun system as a whole, Earth's orbit around the Sun would barely change at all. We would not go flying off into space, and we would not spiral into the Sun. In terms of pure orbital mechanics around our star, Earth would honestly be fine. The far more disruptive changes, as we've already covered, come from everything the Moon does locally: the tides, the axial stability, and the rotational braking, not from any large-scale threat to Earth's path around the Sun. It's worth pausing here to appreciate just how the Moon got here in the first place, because it makes its disappearance feel even more poignant. The leading scientific explanation, known as the giant impact hypothesis, suggests that around 4.5 billion years ago, shortly after Earth itself formed, a Mars-sized protoplanet that scientists have named Theia slammed into the young Earth. The collision was so violent that it blasted an enormous amount of debris into orbit, and over time, that debris coalesced under its own gravity into the Moon we see today. In other words, the Moon isn't some separate object that wandered into our orbit and got captured. It's quite literally made of pieces of early Earth and its planetary collider, fused together and set into the sky. It has been our companion since almost the very beginning of our planet's story, older than the first oceans, older than the first hint of life. And that brings us to one of the most fascinating scientific questions tied to this whole thought experiment. Did the Moon help make life on Earth possible in the first place? Some researchers have proposed that the powerful tidal cycles created by the Moon may have played a role in the early chemistry of life, repeatedly mixing and concentrating organic molecules in tidal pools through cycles of wetting and drying that could have helped complex chemical structures form. Later, as life moved from the oceans toward land, some scientists believe that tidal zones, regularly exposed and then flooded again, may have provided a kind of evolutionary stepping stone, encouraging certain fish species to adapt to life both in and out of water. It's important to say this remains a topic of ongoing scientific debate rather than settled fact, and weaker solar tides alone might still have provided some version of this effect even without the Moon. But it's a striking possibility that the Moon may not simply be a passive companion in our sky. It may have quietly nudged the entire story of life on Earth in the direction it eventually took. There's also a more forward-looking loss to consider. The Moon has been humanity's only real stepping stone into space so far. It's the only other world human beings have ever physically walked on during the Apollo missions of the late 1960s and early 1970s, and it remains the central target of a new generation of lunar missions planned by multiple countries and private companies, many aiming to establish a long-term human presence there within the coming decades. The Moon has also been eyed as a potential source of valuable resources, including water ice at its poles that could be converted into drinking water, oxygen, and rocket fuel, and helium-3, a resource that's rare on Earth but relatively more abundant on the lunar surface, which some scientists hope could one day fuel advanced nuclear fusion reactors. If the Moon disappeared, humanity wouldn't just lose a beautiful object in the sky. We'd lose our closest stepping stone into the rest of the solar system, forcing every future plan for lunar bases, lunar mining, and moon-based staging points for deeper space missions to be abandoned overnight, redirecting our ambitions further out toward Mars and the asteroid belt instead. When you step back and look at everything we've covered, what becomes clear is that the Moon isn't just a pretty light in the night sky. It's a gravitational anchor holding our seasons steady across geological time. It's the engine behind our ocean tides and the ecosystems built around them. It's a stabilizing hand on Earth's rotation. It's the reason our calendars, our religions, and even our language carry its name. It's possibly even a quiet architect behind some of the earliest chemistry of life itself. For something that sits, on average, about 238,000 miles away, doing nothing more dramatic than simply existing and exerting its gravity, the moon has shaped almost every layer of life on Earth, from the microscopic to the civilizational. So if the moon really did disappear tomorrow, the truth is that Earth wouldn't be destroyed. Life would go on. Humanity would adapt as it always has, even as calendars were rewritten, coastlines quieted, nights darkened, and one of the sky's oldest and most reliable landmarks vanished forever. But it would be a fundamentally different world, with quieter tides, wilder long-term climate swings, darker nights, and a night sky that, however brilliant with stars, would always feel just a little bit incomplete. It's a strange thing to realize that so much of what feels permanent and unshakable about our world depends on a companion we rarely think twice about. So the next time you step outside and glance up to see that pale, familiar shape hanging quietly in the sky, take an extra moment to actually look at it, because as it turns out, we owe that quiet, silent rock far more than we ever realized.
Like and subscribe for more videos.